Okay, section 4.6, polynomial representation of integers. Objectives today are to represent numbers in other bases and perform addition in base 2. Now, I will tell you that we're going to be looking at how do you represent numerical values that are in a decimal system and look at them in base 2, base 8, and base 16. Here it says we'll perform addition in base 2. However, you will be required for this class to be able to do addition in base 8, and if you're able to do addition in base 16, which I will go over, then that would be possible extra credit, okay, above and beyond. So, to start with, decimal system. Without even thinking about it, because you've been taught the decimal system since you were born, if I look at the number 1, 2, 3, 5, that represents 1,000, 200, 3 tens, and 5 ones. Each entry represents a particular place value. The last digit is our ones place. The next digit is our tens. The next digit represents our hundreds. And then finally, the last digit represents, or the first digit in the number, the longest one, the one that's furthest away, is our thousands place. Now, the reason that we have a decimal system is because of your hands. We use decimals because 10 makes sense to us. Human beings, for the most part, unless something's happened, have 10 fingers. When you first learned how to count, you learned how to count on your fingers. 1, 2, 3, 4, 5, 6, 7, 8, 9. And as soon as I got to 10, I ran out of fingers. So what'd you do? You'd start over. 11, 12, 13, 14, 15. So every time you reached a value of 10, you had to reset and start over. And that's really what we're looking at. So in a decimal system, every digit represents something times a power of 10. The ones place is 5 times 10 to the 0. Your tens place is whatever the digit is times 10 to the first. Your hundreds place, which in this case is a 2, is multiplied by 10 squared, and then 1 times 10 cubed. If I had another number, it would be 1, whatever that number was, times 10 to the 4th. We have worked with decimals so often that we work with this without even a second thought of what each place represents. If I say 125, you know what 125 is, I know what 125 is, and you just kind of move on. So here, what we're going to do is start thinking, because now we're going to say, okay, well, what if it's not base 10? What if it's some other base? Okay? The nice thing in a base 10 system, decimal, your digits are going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay? That should be familiar because it should look like our remainder classes, 0 through 9. So then we're going to talk about binary. And in a binary system, which is base 2, this is primarily used in programming in computers. Your calculators have algorithms that are based on binary code. Computer programming, it deals with binary. If you look, everything's involving ones and zeros. If I am in a base 2 system, my remainder classes are 0 and 1. So that's all you have. Now if you look on a computer, oftentimes you'll see a switch that kind of looks like that. Okay? And that sometimes turns on and off the computer, but it's a 1 and a 0. So it's primarily used in programming in computers. Every number can be written using powers of 2 instead of powers of 10. And so our goal is to learn how binary works and to work with it. It allows numbers to be seen as a strings of ones and zeros. Okay? So our binary system, every number that you can think of can be rewritten as ones and zeros. And now when the fun begins. Okay, I'll give you a second if you need to write that down to finish writing it, but we're going to do binary. If you can get binary, then octal is just a little bit different, but it's the same type of process. So, moving to the next page. Converting binary to decimal. You're going to have to be able to do two things. If I give you a binary number, you need to be able to convert it to a decimal. If I give you a decimal, you should be able to convert it to binary. So, converting binary to decimal. Let's say I have the number 1101101, and the subscript tells you what form you're in. If you don't see a subscript, it is decimal. So I want to take this binary code and convert it to decimal. This is how it will work. Each digit represents a power of 2, with the furthest to the right representing 2 to the 0. So what I'm going to do here, and again give you a second to write that down, is each of these numbers, 1101101, each of them represents a power of 2. The furthest to the right represents 2 to the 0. Oops, sorry, my apologies. Furthest to the right is 2 to the 0. The next digit would be 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth, and 2 to the sixth. So every digit furthest to the right is always to the 0 power, and then as I move to the left, I keep going up a power of 2. And I believe this is how it's going to look. Okay, spreading it out so it's a little easier to see. So if I'm looking at 1101101, the last digit to the right represents a power of 2 to the 0. Then I have 0, 2 to the first, 1, 2 to the second, 1, 2 to the third, 0, 2 to the fourth, 1, 2 to the fifth, and 1, 2 to the sixth. So to get my decimal answer, all I'm going to do is, if there's a 1, then that means that 2 to the 6 is in play. If there's a 0, then it's not in play. So I have 1, 2 to the 6, which would be here. I have 1, 2 to the 5th. I have no 2 to the 4ths. So if you look down here, I don't have a 2 to the 4th anywhere. I have 1, 2 cubed. I have 1, 2 squared. I don't have a 2 to the first. And I have 1, 2 to the 0. Now at that point, you just need to do your powers. 2 to the 6th is 64. 2 to the 5th is 32. 2 cubed is 8. 2 squared is 4. And anything to the 0 power is always 1. So 64 plus 32 plus 8 plus 4 plus 1 equals 109. So 1101101 base 2 is 109 in decimal form. We'll give you a second and see if you can convert 111001 base 2 to decimal. It's going to go through the same process. Now remember, furthest to the right will be 2 to the 0. I don't have a 2 to the first, I don't have a 2 squared, but I do have a 2 cubed, a 2 to the 4th, and a 2 to the 5th. The 1 means I have it, the 0 means I don't. So 2 to the 5th would be 32, 2 to the 4th, 16, 2 cubed, 8. I don't have a 2 squared because I have a 0. I don't have a 2 to the first because it is also a 0. But I do have a 2 to the 0, which is 1. When we get to octal and we get to sexagesimal system, or hexadecimal system. When we get to the other systems, just know anything to the 0 is always 1. So I get 32 plus 16 is 48. Plus 8 is 56, plus 1, I believe, is 57. Okay, 48 and 56, 57. So my answer is 57. Okay? That's how converting binary to decimal works. Well, obviously, we need to go the other direction now. So next thing we're going to talk about is converting decimal to binary. So to convert decimal to binary, you write all powers of 2 that are less than the given number. So the first thing I'm going to do is whatever number I give you as a decimal, write all powers of 2 that are smaller than it. Then starting with the largest power of 2, use 1 if that power is used, and use 0 if it is not, and we're going to work our way down until we are done. So, let's say I have the number 555, and I want to convert to binary. Now, in doing this, binary is tough because I'm going to have a lot more. When you get to octal, it's not as bad because you're going to be dealing with powers of 8s. But here with binary, here's what I have. I have 2 to the 0 is 1. 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. 2 to the fourth is 16. 2 to the fifth is 32. 2 to the sixth is 64. 2 to the seventh is 128. 2 to the eighth is 256. 2 to the ninth is 512. And then 2 to the 10th is 1024. Okay, well, my number was 555, so the largest power of 2 that is smaller than 555 is 512. So the 2 to the 10th is not in play. Okay? Now, here's the tough part. If I look, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have to have a 1 or 0 for every single one of those 10s. So when I write 555 in binary, I should have 10 places, either 1s or 0s. So what I do is I look, the largest power that is smaller than 555 is 512. Okay? Now, if I take 555 minus 512, because my 512 is accounted for by 2 to the 9th, if I subtract 555 minus 512 is what? 43? So 512 of the 555 I can account for with 2 to the 9th. Now I have 43 left. Well, 256 is too big, because all I have is 43 left. So I can get rid of 256. 128 is too big, because again, I need 43. 64 is too big. So the next value that I have that fits is 32. Now, if I subtract off that 32, I have 11 left that is still unaccounted for. So since I have only 11 left, I can get rid of 16. I can use the 8 though. So I subtract 8 and I have 3 left over. The 4 isn't going to cut it, but the 2 and the 1 both will. So when it's all said and done, if I add up the things that I've circled over here, 512 plus 32 is 544, plus 8 is 552, plus 2 is 554, plus 1 is 555. Okay? So again, here's how it's going to look. 512 plus 32 plus 8 plus 2 plus 1. So here's what I have. My 2 to the 9th is a 1. And then my 8, 7, and 6 were both all zeros. 8, 7, 6 were all zeros. Then I had a 1 for the 5th. Then I had a 0 for the 4th. I had a 1 for the 3rd. I had a 0 for the 2nd. And then for the 1st, okay? And for the 0 power, I have 1, 1. Okay, I know that seems difficult. It's just a slow process. So let's try to do an easier number. Try 113, convert it to binary. Write all the powers of 2 that are smaller than. And then starting with the largest power, use that as a 1. And then I use zeros and ones if I use the value. So give you a second to go. Okay, and I understand for the most part, you guys have never done this before. It's going to take a little time. But I promise you, if you really kind of follow along and do what I'm doing here, it's pretty easy. Okay, you will be able to get it. So with the 113, and again, I'm just doing this for time because we're already about 16 minutes in, and we're on page 5 of 13 pages. Okay, but 2 to the 0 is 1, 2 to the 1st is 2, 2 to the 2nd is 4, 2 to the 3rd is 8, 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 6th is 64, 2 to the 7th is 128, and that's too high. Okay, because I only need 113. So again, here if I look, I have 1, 2, 3, 4, 5, 6. There's 7 different place values that I have to have. So some students will do this. Okay? And then, so I have, if I'm looking to the right would be, this would be the 2 to the 0, 2 to the 1, 2 to the 2nd, all the way out to 2 to the 6. So 2 to the 6, 64 I definitely use. So I'm going to put a 1. Now off to the side here, and I'll change colors, I have 113 minus 64 is 49. So I have 49 left. So 32 is in play. I can use 32. So I'm going to have, I keep changing colors, that's a 1. So over here I go minus 32, and I end up with 17. 49 minus 32 is 17, which means 16's in play. So I have another 1. And then over here, 17 minus 16, I only have 1 left, which means I can't use the 8, I can't use the 4, and I can't use the 2. So over here I'm going to go 0, 0, 0, and then I finish with a 1 because I did use the 1. Okay. Oh boy. Okay, here we go. Octal. Octal is base 8. Okay. Now, we're going to use the same philosophy or the same approach as we did for binary. All digits will be integers 0 through 7. For binary, the digits were 0, 1, and 1. For decimal, it's 0 through 9. Well, for octal, which is base 8, it would be your remainder classes 0 to 7. Similar to binary in that all powers of 8 will be used. So, if I have 735 base 8, and I wish to convert to decimal, the first thing I will do is identify this last digit represents 8 to the 0. The second digit out is 8 to the first, and the third digit is 8 to the second. Probably could have made this a little bit bigger, but here I have 7 times 8 to the second. I have a 3 times 8 to the first, and I have 5 times 10 to the 0. Now again, this is exactly what you do in a decimal system. The only difference is it goes furthest to the right is 10 to the 0, then 10 to the 1, 10 to the 2, 10 to the 3. So in a base 8 system, we're using powers of 8. So I'd have 7 times 8 squared plus 3 times 8 to the first plus 5 times 8 to the 0. So 7 times 64 plus 3 times 8. Remember, anything to the 0 is 1. So I get 7 times 64 plus 3 times 8 plus 5 times 1 equals 477. The nice thing with octal, because you're dealing with powers of 8 get larger faster than powers of 2, so you usually don't have as many digits in your answer. Okay? See if you can convert 21336 base 8 to decimal. Now again, my advice is I would take each of those digits and attach it to the appropriate power of 8. Two, 1, 3, 3, 6, base 8, and I want to convert it to decimal. Remember, the digit that's furthest to the right pairs up with 8 to the 0. Some students will make the mistake and start on 8 to the 1. The last digit's always 8 to the 0. 8 to the 1, 8 to the 2, 8 to the 3, 8 to the 4th. Now 8 to the 4th is going to produce larger numbers, okay, but you have a calculator. So I have 2 times 8 to the 4th plus 1 times 8 cubed plus 3 times 8 squared plus 3 times 8 to the first plus 6 times 8 to the 0. Okay? Pretty much your last digit is always just going to be whatever you see, because 8 to the 0 is going to be 1, 6 times 1 is 6. So really you're just tacking on 6 at the end. So if we come over to the calculator and have it do some work for us, I'm going to go 2 times 8 raised to the 4th plus 1 times 8 raised to the 3rd plus 3 times 8 squared plus 3 times 8 plus 6 times 1 if you want, but plus 6. And the answer is 8,926. 8926. Okay? You guys are doing a great job with this so far. Hopefully you're getting all of this down. As I did earlier, this will get posted. I will publish it to YouTube tomorrow. Well, actually, since you're seeing it today. And it'll be on the Moodle website, so you can go back and look at this later. Converting decimal to octal. So now going the other way. I guess I'll shut this down because you guys are going to start panicking. Converting decimal to octal. If I want 1600 to octal, think about what we did for binary. The first thing we did is we wrote all powers of 2 before, all powers of 2 that were smaller than the number. Here I'm going to write all powers of 8 that are less than 1600. So 8 to the 0 is 1, 8 to the 1 is 8, 8 squared is 64, 8 cubed is 512, 8 to the 4th is larger than 1600. Okay? Then you find how many times. Now this is a little different because binary is easy. It's either a 1 or a 0. So now what I would do is, since 512 is the largest, I need to figure out how many times 512 divides into 1600. Whatever that is will be my digit for that value. So 512 goes into 1600 3 times. 3 times 512, subtracted from 1600 is 64. So my first digit's going to be a 3. Now here, because I have 8 cubed, 8 squared, 8 to the first, 8 to the 0, I know I have a 4-digit number. The first digit's going to be 3 because 512 went in 3 times. 64 was left. So then I go to my next digit. How many times does 64 go into 64? Well, the answer is 1. So I'm going to put a 1. Now when I subtract 64 minus 64, I have nothing left. So since I have nothing left, I don't need to worry about 8 to the first, and I don't need to worry about 8 to the 0. Okay, so 1600 as an octal would be 3100. Okay. Much like before, see if you can convert 5321 to base 8. 5321 to base 8. Now remember, this is a decimal. So you write your powers of 8. Okay. And just to check, 8 to the 4th is 4096. Which is still under 5321. Okay, so I see that there are 5 powers of 8 that are smaller than 5321, so my answer is going to have 5 digits. Now, again, I start at the largest number, and I need to ask myself, how many times does 4096 go into 5321? And the answer is 1. So over here, I'm going to put 5321, subtract 4096, 5321 minus 4096, and I get 1225. So then I go to my next largest number, which is 512. And I need to look at how many times does 512 go into 1225. Now, if I go 1225 divided by 512, I get 2.39 something. So it's going to go in 2 times. Okay, so 2 times 512 is 1024. 1225 minus 1024 is 201. Okay, 1024 I subtract off, and I'm left with 201. So then I go to my next number, which is 64. How many times does 64 go into 201? I believe the answer is 3. 3 times 64 is 192. So 64 will go in 3 times, and that is 192. When I subtract, I have 9 left. So I go to my next one. How many times does 8 go into 9? And the answer is once. And if I subtract 8, I have 1 left. And then how many times does 1 go into 1? 1 time. So your answer is 1, 2, 3, 1, 1. Okay. Now we're approaching the 30-minute mark. Okay, we have a 45-minute class. Okay, so I'm going to take at least a little break here. That's the basis as far as changing things decimal to binary, binary to decimal. This also takes care of decimal to octal, octal to decimal. Okay. The last thing that you are required to do, well, I guess we're going to talk about hexadecimal. I'm going to go through this fast, okay, and then you can go on the video if you want to do this, but this is going to be more geared towards extra credit, okay, especially with addition. But here you should be able to convert You will have to do this, what's on this page, on the quiz on Friday. So hexadecimal is base 16. To do a base 16, now you're looking into, like if you have a wireless router at home and it's secured password, usually you're going to be seeing things with letters. That's going to be hexadecimal. Digits will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, followed by A, B, C, D, E, and F, where A is 10, B is 11, C is 12, D is 13, A is 14, F is 15. Now, if you have, okay, 21EA base 16, and I want to convert to decimal, this is just your powers. So if I look, what I have is, I have 21EA. The A value represents 16 to the 0. 16 to the first, 16 to the second, 16 to the third. Okay? So to find my decimal, I'm simply going to recall that E is 14 and A is 10. So you're going to need to know that. So 21EA16 would be 2 times 16 to the third plus 1 times 16 squared plus 14 times 16 to the first plus 10 times 16 to the 0. Okay? Which is 8,682. Okay? Again, just like powers of 8, just like powers of 2, these are powers of 16. Okay? So, see if you can convert 94D base 16 to decimal. And as you are doing that, I'm sure at some point this is going to start feeling overwhelming. Maybe some of you are already past that point. Remember, we're going to spend 2 days on this. Okay? So unfortunately, because I don't know exactly where we're going to get to in the period, I'm doing the video for the whole lesson. Okay? But we're going to be spending 2 days on this. I do want to get to addition. So I'm going to kind of go through this, and we'll have much more examples on class tomorrow. And so we will take care of this. Okay? So if you're struggling a little bit, may want to go back again. This will be posted tonight online if you want to go and just kind of fast forward to the section that you need. But here, to convert 94D to base 16 to decimal, well, I have 16 to the 0, 16 to the 1, and 16 squared. So I have 9 times 16 squared plus 4 times 16 to the first plus D, which would be A is 10, B is 11, C is 12, D is 13. So I'd have 13 times 16 to the 0. So then over here, just going to take 9 times 16 squared plus 4 times 16 plus 13. Because remember, 16 to the 0 is just 1. So 13 times 1 is 13. Answer, 2381. Maybe. Okay. Okay. So, converting decimal to hexadecimal. Now, nice thing, the larger our power gets, the less work you have to do or the less digits you'll have. You'll still have some work. But here, I want to convert decimal to base 16. So much like before, I need to write all the powers of 16 that are less than 2959. Well, 16 to the 0 is 1. 16 to the first is 16. 16 squared is 256. How many times does 256 go into 2959? Come over here. 2959 divided by 256 is 1.15. Sorry. 2959 divided by 256. My apologies. 11.5. So the answer is 11 times. So the first digit's going to be the letter B, because 11 is B. So I go 2959 minus 11 times 256, and the answer is 143. So I should have 143 left. Then, how many times does 16 go into 143? 143 divided by 16 is 8.9. So the answer is 8. So my second digit is 8. And then I go 143 minus 8 times 16, and I have 15 left. So my last one that I need to look, how many, last digit would be 15, because how many times does 1 go into 15? The answer is 15. So the last one would be F. Okay. 2959 converts to B8F16. Okay. And again, for time purposes, I'm going to go ahead and just do this. Our bases of 16, 16 to the 0 is 1, 16 to the first is 16, 16 squared is 256, and just for the heck of it, 16 to the third is 4,096, which is way too high. So here, I only have to start at 256. So because there are 3 powers, I know I have a 3-digit answer. So the first digit, I'm going to take 1115 divided by 256, and I see that 256 goes in 4 times. So my first number is 4. Take 1115 minus 4 times 256, and I see I have 91 remaining. So if I had 1115, and once I do my subtraction, I have 91 left. So take 91 divided by 16, and the answer is 5.6875. So I know my second digit must be a 5. 5 times 16, I believe, is 80. So if I subtract off that 80, I end up with 11 left over. And then my last one, how many times does 1 go into 11? 11 times. Now 11 would be letter B. Okay? So, last thing I'm going to get to, and as soon as we're done with this, I'm going to tell whoever the sub is to put a pause on things, and we'll pick up tomorrow. But here's how addition works. Okay? To do binary addition, this should be plus. If I have 11011 plus 10011, when you add, anytime you reach 2, you have to carry over. Just like in a decimal system, anytime you hit 10, you carry 1 over to the next column. So here, 1 plus 1 is 2. But I can't write 2 because in binary, 2 doesn't exist. So I put a 0 and I carry 1 over. So then 1 plus 1 plus 1 is 3. But every 2 carries over, so if I have 3, I'm going to put 1 down and carry the other 2, become a 1 in the next column. So then here, 1 plus 0 is just 1. 1 plus 0 is 1. Here, 1 plus 1 would be 0, carry a 1. And so my answer is 101110. Okay? Every time you reach a total of 2, you must carry 1 to the next column as you work from right to left. 1 plus 1 is equal to 0, carry the 1. Okay? So, if I give you a larger one to do, we have 111011 plus 101010. Start at the right, work your way over. 1 plus 0 is 1. 1 plus 1, I'm going to write a 0 and carry a 1. 1 plus 1 plus 0 is 0, carry a 1, because I added up to 2. I put a 0, carry the 1. 1 plus 0 is 1. 1 plus 1, I put a 0 and carry 1. 1 plus 1 plus 0, I will write a 0 and carry the 1. And then this one, 1 plus 1 plus 1 would be 3. 2 of the 3 will carry, so I only put a 1 and then carry a 1. So I get 1, 1, 0, 0, 1, 0, 0, 1. Usually at this point, someone's head just spun. Okay? Binary. Octal addition. Octal addition. You're going to add, since we are in base 8, when you add digits, we carry 1 whenever the column sum hits 8 or more. Okay? So if I go 5 plus 7 adds up to 12, but in base 8, I would write 4 and take the remaining 8 and go to the next column. So we write 4 and carry a 1 to the next column. So here, if I'm looking, the first column to the right is 7 plus 5, which is 12. But in base 8, I would write a 4 and take 8 of that 12 and take it to the next column. So here, 6 plus 2 plus 1 is 9. 8 goes into 9 one time with 1 left over. 6 plus 2 plus 1 is 9. 9 divided by 8 is going to carry 1 over and then 1 remainder. 3 plus 4 plus 1 is 8, so I'll write a 0 followed by a 1. 1 plus 5 is 7. Don't have to do anything. And then my last column, 7 plus 1 would be 8. So I'm going to write a 0 and carry a 1. Okay? So if I had 7 plus 3 equals 10, we would write a 2 and carry a 1 to the next column. Okay? Now I know this seems really confusing, but if it makes you feel any better, you already do this in base 10 without thinking about it. So it's just thinking about it a little bit. So here, 5, 5, 3, 6, 7, plus 4, 6, 7, 1, 3. And I'm adding in base 8, which means I can't see any 8s. And if I go above 8, I need to subtract 8, carry 1 over. So here, 7 plus 3 would be 10. 10 minus 8 is 2, and then I carry the 1. 1 plus 6 is 8, so I write a 0 and carry the 1. 7 plus 3 plus 1 is 11, so I put a 3 here, because I take 8 of the 11, carries to the next column, and then the remaining 3 is there. 6 plus 5 plus 1 is 12, so I'm going to put a 4 and carry the 1. This is 4 plus 5 plus 1 is 10, so I'm going to put a 2 and carry a 1. And there's my answer. Okay? And I'm sure probably you guys have already wrapped up. But we'll go and finish hexadecimal addition. I'm just going to kind of walk through it, but it's going to be very similar. So here's how we have it. Let's say I have 4, 5, 9, A, D, plus 3, 2, F, 8, 8. Okay, and these are base 16, and I want to add. Now again, this here would definitely be extra credit. But if I look, remember, A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. In base 16, we got to go up to 15. So really, if I look, this is a 15 here, and this is a 13. Okay, so if I'm adding, 13 plus 8 would be 21. But in a base 16 system, 16 of the 21 would carry over, and I would just have left 5. 16 goes into 21 one time with 5 left over. So then my next column, A is a 10, so I have 10 plus 1 plus 8, which is 19. But in a base 16, 19 would be a 3, carry a 1. Okay, 19 minus 16, take 16 over to the next column, and then I still have 3 left. Now this one, I have 1 plus 9 is 10, plus 15 is 25. 25 minus 16 is 9. Carry the 1. Next one, 5 plus 2 plus 1 is 8. Finally, we don't need to do anything because 8 is less than 16. And then last column, 4 plus 3 is 7. Now if I did have, like say it was 4 plus 8 and I get 12, then I'd have to write a C here. Okay? Homework assignment. Pages 262 to 263, 1 through 18, skip number 14, do your best.